Hello, this video is for Notes 7.3 and Homework 7.3. The topic is rational exponents. So let's get started. Better start at the beginning. Okay, if you recall, rational numbers are any numbers that can be expressed as a fraction, where both the numerator and the denominator are integers. Since rational numbers are numbers that can be expressed as a fraction, rational exponents are exponents that are fractions. All right, now here are the two main rules that you see on the screen. They're also on your notes. If you know how to use these rules, that's fantastic. The next several minutes, though, I'm going to go over why these rules work. So we'll derive them for you according to the exponent rules that you already know. So first of all, you'd probably agree with me if I told you that the square root of x squared equals x, because the square root of x squared is square root of x times square root of x, which equals x, or x to the 1. You would likewise probably agree that if we use the power to a power rule, x raised to the 1/2 power squared would equal x to the 1, because we would multiply the two exponents, and 1/2 times 2 is half of 2, which is 1. So what does this mean? Well, if x to the 1 is the same as square root of x squared, and x to the 1 is also the same as x to the 1/2 squared, then it stands to reason that x to the 1/2 is the same as square root of x. Or in other words, if we have a fractional exponent, the denominator becomes the index of the radical. So if I take x to the 1/2 power, for example, it becomes square root of x. If I put it in general terms, if I have a fractional exponent that's 1 over any number, that n, any number, becomes the index of the radical. Let's look at the other rule and how we derive it. You would probably agree that a to the 2/3 is the same as a to the 1/3 times 2, because 1/3 times 2 is 2/3. Fair enough? Well, using the rule that we just learned, any number raised to a fractional exponent, I would take the denominator of that exponent and make it the index of a radical. So a to the 1/3 power is the same as the cube root of a. But then we have this square left over that still remains. So we can say that a to the 2/3 power is the same as the cube root of a squared. So notice what happens to both the numerator and the denominator. The denominator becomes the index of the new radical, and where the numerator stays as an exponent. We can also write this a different way. So this top row is from the previous slide. It's what we just said. Well, the only thing different on this second row is that I've now called 1/3 times 2, 2 times 1/3, which of course is the same thing because of the commutative property of multiplication. So a to the 2/3 power is the same as a raised to the power of 2 times 1/3, because 2 times 1/3 is 2/3. But then we can use the same rule we learned earlier, that any number, like a squared, that is raised to the 1/3 exponent, the denominator 3 would become the index of the new radical. So in other words, we're taking a cube root of a squared, a cube root of a squared. So again, if a to the 2/3 equals this thing, and a to the 2/3 also equals this thing, then that means that these two things must be the same. And that's just from the transitive property of equality. So if I take the cube root of a and then I square it, that's the same thing as taking the cube root of a squared. A couple of quick examples. If I take the number 25 and raise it to the 1/2 power, all I have to do to rewrite this as a radical is move that denominator of 2 in the exponent to the index. The numerator remains as an exponent of the base. So 25 to the 1/2 power is the same as square root of 25, which of course is 5. 2 to the power 6/3. Now 6/3 of course equals 2. So this should be just 2 squared, and we can see it is by looking at the answer. But let's take it step by step. 2 to the 6/3 power. I should be able to take this denominator of 3 and write it as the index of a radical. And then I take the numerator 6 and leave it as the exponent. So I get cube root of 2 to the 6th. Well, as it turns out, 2 to the 6th power is 64. 64 is a perfect cube because 4 times 4 times 4 is 64. At the bottom of the notes page, I apologize because this did not come out well in the copy. However, you can easily see the relationship here with fractional exponents. The top row, we're just rewriting each radical as a power. So cube root of 7 becomes 7 to the 1/3. Remember, the index of the radical is the denominator of the fractional exponent. The 5th root of x becomes x to the 1/5. Remember that if there is no index, it's a square root. So the square root of y is the same as y to the 1/2 power. Now we'll go in the opposite direction and write each power as a radical expression. So 8 to the 1/4, the denominator of 4 in the exponent becomes the index of the radical. So 8 to the 1/4 is equivalent to the 4th root of 8. Z to the 1/5 becomes the 5th root of z. And finally, m to the 1/3 power is equal to the cube root of m. On the back of the notes sheet, there are 2 examples. Example 1 features 2 different ways of doing it. Method 2 I think you will find is easier, but I wanted to show you both. So if we want to simplify, the quantity 9n to the 4th power, all of that raised to the 3/2. We would like to get rid of any fractional exponents if we can. So the first thing that we'll do is rewrite this as a radical. I'll take the denominator of my fractional exponent and make that the index of my radical. The numerator of the fractional exponent stays with the quantity. The next thing I did was I realized that this exponent of 3 applies to everything in the parentheses. So this 9 is raised to the 3rd or cubed power. So I get 9 cubed, and then n to the 4th cubed. I multiply those exponents because of the power to a power rule to get n to the 12th. Next, I will simplify the radicand by extracting perfect squares from it. Since we're taking a square root, I'm looking for a square hiding within 9 cubed. Well, 9 cubed is the same as 9 squared times 9. N to the 12th becomes n to the 6th squared. Now I have two perfect squares that can be extracted from the radical. The square root of 9 squared is 9, which comes out as the 9 in front of the radical. The square root of n to the 6th squared is n to the 6th. So that comes out of the radical as n to the 6th. The 9 stays under the radical for now. However, I can square root that as well. The square root of 9 is 3, which comes out of the radical and multiplies by the 9, which gives us 27n to the 6th. So as it turns out, 9 cubed is a perfect square itself. Now here's the other method that I think is a little bit easier. What we want to do is rewrite everything inside the parentheses as a power. So I rewrote 9 as 3 squared. And I raised it to the 3/2 power because that's the exponent that applies to everything in the parentheses. N to the 4th is also raised to the 3/2 power. Now I use the power to a power rule and multiply the exponents. 2 times 3/2 is 3. 4 times 3/2 is 6. And that's our answer. We can simplify 3 cubed by turning it into 27n to the 6th. All right, the next example is the quantity 8x to the 9th, all of that raised to the 5/3 power. Let's rewrite everything inside the parentheses as a power. 8 is the same thing as 2 cubed. So I rewrote it as 2 cubed, x to the 9th, all of that raised to the 5/3. Now I will use the power to a power rule, which means I take the exponent of 3 and multiply it by 5/3. 3 times 5/3 is 5, so I get 2 to the 5th power. The x term, 9 times 5/3 is 15, so I'm left with x to the 15th. We can rewrite 2 to the 5th as 32. So our final answer is 32x to the 15th. So let's look at a few examples from the assignment. Number 11 on the assignment, we're supposed to rewrite it as a radical. So I will rewrite this as radical, and remember that our denominator becomes the index, and I will have 5n under the radical roof. Now here's something very important to remember. This numerator is going to end up being the exponent of the base. However, the base is everything in the parentheses. Therefore, I must also have parentheses under the radical roof. So that's my answer for number 11. Similarly, for number 16, I'm going to rewrite the radical as a power. So when I rewrite this, since I'm taking a root of 2m, then I must have 2m in parentheses. There is no index written, which means it's a 2. My exponent is 3, which means my fractional exponent will be 3 over 2. And finally, let's look at number 22. We need to simplify this. The first thing that I'll do is rewrite what is inside the parentheses as powers. 81 happens to be 3 times 3 times 3 times 3. So 81 is 3 to the 4th power. We're going to raise that to the 3/4 power because of that 3/4. Then we will multiply this by n to the 8th to the 3/4. Using my power to a power rule, I will get 3 to the 4 times 3/4, which is 3 cubed, n to the 8 times 3/4, which is 6. This gives me a final answer of 27n to the 6th, because 3 cubed is 27. And that is my answer. So if you guys have any questions on this, feel free to send me a message on Remind or an email, or post something on Google Classroom. I'm happy to help, even if it's the weekend or in the evening, that's fine. I'll get back to you as soon as I can. I hope you guys are staying safe and helping to take care of each other. And I'll see you next time.